It is both an honor and a privilege to welcome a truly extraordinary mind and one of the two main characters of my novel today. My guest needs a little introduction, for he is renowned worldwide as a pioneering theoretical physicist and interdisciplinary researcher. His innovative approach to scientific inquiry, integrating theoretical physics, cosmology, biology, philosophy, and spirituality has reshaped our understanding of the universe. He is the brilliant mind behind the tetrahedral networks theory, a groundbreaking concept that bridges the realms of quantum physics and the macroscopic dimensions of the cosmos, unveiling the mysteries of gravity and the structure of the quantum vacuum. Not only is he a leading scientist, but he is also the founder of the Resonance Science Foundation, an organization dedicated to promoting scientific research and education. Through his lectures and publications, he has inspired countless students and researchers, sparking new avenues of exploration in the realm of theoretical physics. Today, I'm honored to have with me the visionary scientist Nassim Haramein. Welcome, Mr. Haramein, and thank you for joining me. Let's start the interview right away. Well, what kind of a child were you?
I was a problem child. I think I made a lot of difficulties for my parents. I was when I was born, I was not ingesting all the food that my parents give. I would vomit the food out, and so I refused to eat for almost 8 months like this. And so they got very worried about me, and they had to go to the doctor, and I was crying a lot, and so they had to put kind of jelly or glue in the milk so that it would stay inside me. And then I grew up as a really kind of uh, uh, lonely child, because um, I didn't fit well inside the school system. And although my father was a child psychologist and a well-known child psychologist that worked with Piaget and all this in Switzerland, um, I really kind of had a lot of difficulties at school. I'm very dyslexic. Um, I didn't do well reading, I was not so interested. I didn't feel like what I was learning was relevant or important. I didn't feel like I fit. And by that time, my father had taken a position at the University of Montreal, and I was so he was the director of the child psychology section of the University of Montreal, and I had difficulties at school because as well the color of my skin. At the time there was not so many immigrants in the schools in Canada, and so I there was a lot of racism, bullying, and all this. So it was pretty tough. I had a crazy childhood, a little bit difficult.
Well, thank you. Well, and what age did you become passionate about research?
That well, I from when I was really young, I was passionate about research. So if you mean formal research, then that was in my mid-20s. But before that, when I was young, I was very interested to understand nature, to understand, but not just nature, like the flowers and the trees and nature like that, but nature like the nature of reality. Very interested in the nature of consciousness, like what was going on in people's mind. My father being a psychiatrist, a psychologist, and like my my mother was very intelligent. We had deep discussions even when I was 6 years old, 7 years old, about the nature of reality and how people thought about reality and what they meant. And I remember doing like exercise in the buses when I was in the bus, or in the metro, or walking on the street, or I had a cinema near me, and I would sit on a bench and look at the people come out of the cinema, and I would try to figure out uh certain kinds of people, and try to figure out like if there was like patterns in the way people were, like the way they acted, the way they looked, the way they walked, the way they talked to each other. I was looking for patterns very early on. So I would say really early on,
Uh, and are there any other scientists in your family?
Yeah, well, my father was a scientist, in psychology, and a scholar. Uh, but you could say my grandfather on the Iranian side, in some ways, was a scientist. He was interested in science, uh, but from another perspective. Uh, as well, he was an imam and in Iran, and he brought people on camel's back to Mecca, which took 6 months in the desert on camelback.
Interesting.
Yeah.
It's
And
something
then six
special.
months back, so a year journey. And he would bring all the prayers of the people that could not go, and bring the people that could go. And so he had many different adventures during these like long journeys. He was said to have like birth, I don't know how many kids, during the year journey, because like people, some of the people he brought would, like, the women would become pregnant, and children during the journey, and so on. And so he birthed many kids, and I think he was very deep thinker, I believe. So I would consider that scientific scientist, but as well, or philosopher at least. Um, as well, he lived very old. It's unclear exactly until what age, but between 120 to 128 years old.
Hola.
Yeah, yeah,
Incredible. I can't believe it.
yeah,
It's a special
yeah. It's
family.
amazing.
It's amazing, really. Uh,
Yeah.
uh, let's speak about your theory of everything. Why does it concern other scientists?
Well, finding a unified field theory would mean to really have a whole deeper level of understanding of the nature of reality. And having a deeper level of understanding of the nature of reality always leads to more advanced technologies. Um, and if it's a unified field theory, if it's a theory of everything, which I don't really like the terminology of that, but if it's a theory that includes more than physics, like biophysics and biology and cosmology and all this, um, then it's something that can have huge impact. Uh, for instance, for health, longevity of life, for transportation, gravity control would allow us to explore the solar system in a very easy way and transform the way we move goods on the planet and everything. Um, Energy production, would transform the way we produce energy and give us opportunity to have free energy, like energy that is not like destroying the environment when we use it and so on. And so it would have really deep impact for humanity, and including information about ourselves, about our consciousness, about how the universe works, how we interact with the universe, and how, like, what is life, what is existence, what is consciousness, like all these questions could eventually be answered by a theory of everything, by a theory that unifies physics. And I believe I found something, at least like the beginning part of this, that's really powerful, very powerful. And I just published a paper that is going viral. There's like some 22,000 downloads, which is very rare for physics paper. Like, people don't just download physics papers, especially not 50 pages physics paper, and read this before bed at night.
But will
People
they be
just
public? Will it be possible to read them in a short
simple terms.
future?
Yeah, I give the technical seminar a few weeks ago, and I give the layman seminar a few weeks ago. So the technical seminar, people can see. I'm gonna write material
Mm.
to so that's written in simple terms, so that everybody can understand the theory, and because it's actually really simple. It looks complicated because it's got all these equations. You see behind me, there's equations everywhere here.
It
But
looks complicated because I try to
yeah,
read a lot of documents, a lot of information found on the internet. It's not so easy for someone like me who isn't a scientist, but I'm so curious. I'm reading a lot about you because, and I'm very happy to have this interview with you because I want to learn a lot about your research that is really interesting. And every time I read something, I learn something new. And I think that it's important for everybody to know what you found, what are your papers about. And I'm sure
yeah,
many people will read and try to understand more about all the researches you did in the past and nowadays.
I'm gonna try to make it more and more simple for people to understand. You know, it's not easy, because not because it's complicated, it's just because there is a lot of formalism, formulas. And when I talk about it, I have to talk about it in terms that are precise enough so that the physicists don't think I'm saying wrong things, you know. but not so precise that the person that's not a physicist doesn't understand anything I'm saying. So it's a very difficult balance to
Yes,
find. Yeah,
I
yeah,
can believe it. Yes.
yeah.
Another question, is it possible to be a scientist and have faith?
To be a scientist and have faith, like religious faith.
Yes, yes.
Of course, yeah, of course. Science doesn't remove, you know, religious faith. Um, what I would, that's a really good question. I've never been asked that question, so that's a really good question. I think that, I think that, I mean, for instance, there's a lot of scientists at the Vatican that are Christian, and so on. Um, it's not because, and I can see how they can, have both, because they say, well, it's not because I want to understand the mechanics of how God makes the world, that doesn't mean that there's no God, right? So
Yes.
the two are compatible, you see. I prefer not to be involved with any religions,
Mhm.
because I think, although, then there's scientists that are not religious, where physics is their religion, and uh that's a big problem, because um uh science is about constantly exploring new ideas, and if it becomes dogma, if it becomes religion, then it becomes a problem, because it should not be dogma or religion. It should be what we discover, and if it makes sense, and if it's more simple and more beautiful, then that should be where we go, not what was established before, by others that may have got pieces, but not the whole thing. And so, that can be dangerous, physics. But the I would say that I have faith, although I'm not religious. You know, I would say I have faith that, um in the sense that I trust and I believe that there is an organizing principle, meaning that the universe is not just this random thing that happened by miracle, like some kind of, like, crazy random fluctuation that all of a sudden made humans, but it really didn't want to make humans. It just happened. It made animals, it made trees, it made everything, so that eventually everything could work together, like by this big chance. I don't believe that. I don't think Einstein believed that neither. So without believing in religious, figure, I still have faith that there is a fundamental organizing principle, and I think I've found how it works. And so it it I have faith in all of the connection of humanity. I have faith in humanity. I have faith in, the universe, meaning, like, in the nature of the universe, in the nature of creation. I think it's beautiful. I think it's incredible, and I think that it's a miracle, like that it exists, and that we can be in it, and all this. So in that sense, I have faith.
Mhm. You spoke about Albert Einstein, and you continued the studies of Albert Einstein, who never managed to develop a theory unifying electromagnetism and gravity. If you
Yeah.
could speak to him, what would you say? What would you say to Einstein?
I would, based on what I know of Einstein,
Yes,
meaning like there's maybe he found things that he didn't publish or that he didn't say, but based on what I know, I would say to him, you came that close. You came that, you were so close. You were so close. And but they didn't, but at the time he didn't have the tools we have today. He didn't have the discoveries we have today. You know, people say, "Oh, but if Einstein couldn't find it, why do you think you could?" And it's the answer to that is easy. I have so much more opportunity than Einstein. You know, uh, even
in
if it's just from being able to do a search on the internet like this and get any information I need
nowadays.
for like
Mm-mm.
like just like this in 10 minutes, where, in his time and in my earlier time, you had to go to the university library. And then you had to like go through like the little cards. You remember the little cards? All
Sure,
the little cards trying to find the
it's
book,
true.
or
It's
the
true. I
paper. And then
remember.
you had to look for the book in the library. And if it was taken out by somebody else, then you had to wait,
Mm-mm.
and you could wait like a month before it came. And if it wasn't in your library, then you had to order it from another library. It could take a month before you got it. And so it's like the amount of information we can have access today in one day is so much more. And so this and then as well all the discoveries, like for instance when Einstein wrote relativity, when he wrote general relativity, he couldn't solve the equation. He published the paper saying it's something like this, but I can't solve it. And the first solution was found by Karl Schwarzschild, which was a German physicist. And when he solved the equation, it said that his equation made no sense, meaning that the result of Schwarzschild's solution to Einstein's equation was a black hole, a singularity, a point that has infinite density that absorb all the electromagnetic fields. And that didn't make sense to Einstein. He said that probably doesn't exist.
Mm-mm.
This is my theory predicts something that doesn't exist. But then they looked at the weak part of the field, like far from the black hole, and they found that, like, yeah, it matched observation, right?
Mm-hmm.
But he didn't have the opportunity of today, where black holes have been observed and we know they exist, and it's a big part of astrophysics. And he didn't have that opportunity. He didn't have all the experiments in quantum physics. He didn't have all the things that we have today. So for him to solve it was almost impossible. But today it's another story. And actually, the way I solved it is really obvious and simple. I mean, in terms of physics, it's
Yes,
simple.
in terms of
Uh,
physics. Mm-hmm.
yeah, and
Yes, but
it really just says that the vacuum structure, that space-time is not empty, it's full, and it has a energy that curves space-time into little balls that we call particles at
mm,
the quantum scale. So it uses Einstein at the quantum scale, and it makes up our world.
okay, thank you. What are the questions, if there are, that science cannot answer?
Is the question, is there any question that science cannot
Yes,
answer?
cannot answer. I suppose that there are. Yes, I know that maybe to think about the questions now
It's maybe you
Um,
have to think about that a little, but I suppose that there are.
Well, you see, for me, I don't see science and reality as two different things.
Mm-hmm.
Okay, there's only reality, the way the universe works, and then there's the little human writing mathematics and concepts, and we call that science,
Mm-mm.
right? So, uh, is it possible that you get to a place where you cannot write or make the mathematics, like translate what the universe does in mathematics or into conceptual notion? I would say no. I say I don't see why, because we're inside the universe. We're made by the universe.
Mm-mm.
We're part of the universe. So so of course we can write the concepts of the universe, the way the universe work. We can, like, I don't see why there would be a place where we can't write physics anymore. Like, it's too difficult, or I don't see why that would be true. Um, of course, uh, but at the same time as I would answer that way to your question, I would say, on the other hand, I don't think we'll ever get to the end of it, meaning there's always going to be new level of, like, wow, how does this thing work? And, new level of discovery. I don't think we're going to get to, like, oh, we figured everything out and nothing else to figure. Now we're going to be bored for the rest of eternity, because we're not going to have anything to do because we figured it all out. I don't think we're ever gonna get to that. So in that sense, you could say there's always gonna be new questions that are not answered.
Okay. And how could the theory of everything be applied in the everyday lives of ordinary people?
Um, well, you see, one of the qualities of the theory of everything is that um it includes you. Because you're part of the everything, right?
Yes.
And yeah, and so to actually understand, in fact, it might remove most of the religious belief. You see, it might remove most of the, because it basically says that you're connected to the whole thing.
Mm-mm.
It basically says that you're not, like, separate from the universe, but you're part of the universe, and that the universe is interacting with you, and you're interacting with the universe. And that might be hard for you to visualize, but because we don't see ourselves as very complicated, right? We see ourselves as one person. It's not complicated, it's one person, right?
Mm-mm.
But in fact, we're made out of 100 trillion cell, or 50 to 100 billion cell, and in each cell is 100 trillion atom, right? And then each side atoms, there's protons and neutrons, and inside those, according to what I found, there's, like, well, I mean, according to the standard model, there's quarks, and then eventually, what I found is that there's Planck's billion trillions of Planck. It's super complex. You're like, I could see you as, like, a universe on your own, right?
Yes.
I- and so, like, if I was a Planck, which is like the smallest electromagnetic fluctuation we have, um, if I was a Planck, you would look at it like the universe to me,
Mm-mm.
right?
Yes.
Because in the scale between the Planck and the universe, the human is almost in the middle.
Yes.
So, so from the Planck, looking at the human, it would look like the universe, right? But for you looking at the universe, it looks so you see, it really is like a perception, and it really is like learning about this. All of a sudden you start to feel, okay, I'm part of this incredible, so it changes your perspective. It changes your perspective of the universe, about what life is, about what consciousness is, about how important every moment matters, how important we are to each other, how important, how unified we really are, like how insignificant it is, all of our little disputes, you know, viewed from the universe. If you were looking from space
Mm-mm.
at the earth, you wouldn't see, oh, Hebrew people, oh, black people, oh, white people, or Chinese people. You wouldn't see that.
Obviously. No.
Yeah, you would just see little earth, a little teeny dot, like little earth, like, and if you look closely, maybe you would see humans, but you'd think, oh, it's humans, right? You wouldn't see the different, like the
Difference
difference wouldn't
between
matter.
the one and the others. Sure. It's true.
Right.
Mm-mm.
And every astronaut that to space, they report that feeling. When they come back changed. It's a very known phenomenon. It has a name, I can't remember it. But it's known phenomenon. They realize, oh, there's no lines between the countries. We always look at the map, and they put the different countries in different colors with lines, like that's not real, like there's no such thing, right? And so it will change their mentality, but as well, it will change their life, because if you have energy that coming directly out of the structure of space-time, you have energy for your car, for your house, for everything. You can have as much energy as you want to do anything. You can desalinate salt water from the ocean and greenify, like deserts, and you can, grow anything because you have infinite amount of energy, and then you have gravity controls, so you can fly throughout the solar system, everything. Like your life is completely different. So like, and this new level of technology can bring all this. It's the next level. It's really powerful. It, it says far from like modern civilization, that like, for you, like to have a smartphone, that like you can have, you know, conversation with your friends and see them and all this, no big deal. Well, this is crazy for a guy 150 years ago. That was like crazy, that's not possible, right?
And
Well,
mm-mm.
the future of only like, because it's an exponential evolution. So only like uh, a few decades from here, we could have gravity control, we could have infinite amount of energy, we can have a very, 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 very different life than
Mm-mm.
the life we have today. And hopefully a unified earth, because we realize we're all on this little grain of sand, flying through space. And we better work together, because it's otherwise we're all gonna perish. It's
Mm-mm.
really ridiculous that we don't.
Yes.
And in general, I want to say, in general, people want to work together. People in general are lovely to each other. People in general want to help each other. People in general, it's just that we have created a structure, power structure, that lives on conflict, and lives on and where the financial structure benefits benefits from conflict. So then, there needs to be conflict. Otherwise, the system doesn't work.
Yes, really. And what is your greatest achievement, and do you have any regrets, if any?
Wow. Um, it's hard not to have regret, you know?
Mm.
Like, I have a son um that's turning 18, and I see him becoming a man, and like starting his life, and wanting, like, he's got a car, and he's gonna get a car, and then he's getting a job, and now I'm not gonna see him as much and all this, and I was thinking about it. I think all parents go through this at one when their leaves home, right? Oh, I have regrets of how much I worked. I worked 15 hours a day, many weekends, and all this. I would have liked to spend more time with my
With
children, all this. And so I do have regrets about certain things. Um, but I think I've lived my life full on. I've always lived with full intensity, and as much as I could in every day, because it became apparent to me very early that 80 years or 100 years or 120 years, like my grandfather, is actually very short, and so you have to, like, make the most of it. Um and yeah, I mean, I wish I had regrets about not, following the typical, you know, uh, how do you say, uh, um, uh, path of study. Like, I didn't go to universities and all this. I studied independently. I'm an autodidact. Many other physicists that were really well-known physicists. And in some ways, Einstein was thought to be an autodidact. But you know, the 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 main thing is that, like, I wish in some ways that it was it would have been easier for me to, like, get heard, by the scientific community earlier, if I was in other circumstance. But at the same time, many things I found because I was an independent thinker, because I was studying outside the universities and all this, and I was allowed to think my own thought, go through the physics in my own way, you know like, see what I thought was good, and see what I thought was wrong, and then kind of like try to fix the wrong ones, which I don't think I would have been able to do if I would have gone through the classical, educational system. So I needed to be outside, but it made it, and it still does make it so much harder.
Okay. You talk about black holes within all celestial bodies, the sun and even the earth. And from these black holes, energy would be generated. Could the stargate of the sun be a portal then?
Yeah, I even go further. I talk about the nuclei of atoms, the proton as a black hole. This is what I just published.
Yeah.
And the math all works, and it's very powerful, as it describes the force that holds the nucleus of the atom together, and then eventually gravity. But yeah, and stars, well, you know, current theory says stars explode. See them explode. We call them supernova, right? So we see star exploding, and people when they think about that, they think, oh, here and there, because it takes thousands, millions, if not billions of years, right, for a star to explode, right? But so since it takes so long, when we think about that, we think, oh, it must be pretty rare, you know. But if you actually look in the galaxies in the universe, it's like this, right? It's like star exploding. It's like light bulbs at Christmas, you know, they blink it out, right? And when they do, um, then when they do, and that's just because there's billions and billions of stars, right, in a galaxy. So, you know, so when they do, what we find after is a black hole. Okay.
Uh-huh.
And their theory says the black hole was made by the explosion,
Mm.
which have like is inconsistent mathematically. There's issues there.
Mm-mm.
What I'm saying is that the black hole was there first, and that's what made the star. And then when the other layer of the star explodes, you see the black hole again. You see, um, and and the proof that I'm correct, mathematical proof, is I'm publishing in the next few papers. But the proof, the conceptual proof that I'm correct is that I predicted with this that we were going to find black holes in the center of all galaxies. This is before we thought that black holes existed. This is in the 80s and 90s. And then we found black holes in the middle of every galaxy. At the same time, I predicted we were going to find black holes prior to the galaxy creation. Because when we look in the universe, we look back in time. You know that, right? We
Yes.
don't look at the universe the way it is right now. In fact, we have no idea what the universe look right now is unknown to us because what we see is the light that reached our telescope, right? And or our eyes. And so when we look, we're looking at light that traveled for thousands, if not hundreds of thousands or millions of thousands, you know, of years, right?
Yes.
Like billions of years. And so when we look in the universe, we look back in time towards the early universe, what they call the Big Bang. And when we look there, what do we see? We see very, very, very large black holes that eventually become the heart of galaxies. So I predicted that. So it's correct. It's correct. Black holes were there before galaxies, and now they understand this because of observation, but they haven't figured out the stars. Black holes are there before the star,
Uh-uh.
and there's more and more evidence that black holes connected by wormholes, right? In
Yes.
theoretical physics, showing that black holes are like the hubs of a network of wormholes. And so, if that's true, um, you could jump in a black hole and use the network of wormhole to go to another black hole on the other side of the galaxy or on the other side of the universe, and then jump out, and there you would be. So yeah, is the black hole in the center of the sun a portal? I would say yes, and I would say that um there is evidence of the portal on the surface of the sun, and we call those sunspots, which are huge vortices, sometimes 15 times the size of the Earth, huge vortices, where you see the spiral of like plasma being sucked into the sun, just like you would expect, matter falling into a black hole, near a black hole. So I think those are portals, if you'd like.
Very good. Uh, can we assume that what was once believed to belong only to novels and fantasy movies is becoming a reality?
Absolutely. I think so. Absolutely. Just like you know, the telephone was in science fiction before it became real. Like the refrigerator was in science fiction before it became real. The submarines was in science fiction before rockets was in science fiction before it be science fiction is always ahead of where we're going, because you know why? Because it has to be in the imagination of a human, right? Before
Right.
it becomes reality. Anything that is invented, anything that discovered was in the imagination of somebody. And if somebody is able to have complete imagination without having to make the device, then they can have complete freedom to imagine the most amazing things. And because they're made by the universe and they're inside the universe, what they imagine is most likely gonna something that's possible.
Mm,
You see?
sure.
So so science fiction for the last 2 decades, 3 decades, for the last 30 years, 40 years, has been telling us about black holes and wormholes, and because of theory from Einstein and all this, and because people's imagination and like warp drive and being able to travel through space, it the first Star Trek communication device was a little flip phone, it was a little smartphone,
Remember.
right? It was long before the smartphone, right?
Mm.
And they had like a touch screen, and they could like touch on the screen and it would work. Like this was long before touch screen, and so on. So yeah, I totally think that like we're actually starting to actualize, and we will actualize what we've seen in the science, like science fiction movies.
Mm, very good. When will you come to Italy to talk about your research?
I would love to go to Italy to talk about my research. I live like a half an hour from
You are
Italy.
close to Italy now. Not
Yes,
very
yes.
far.
So I would love to do that. I'm planning on doing a tour with the paper I just published to explain it to people. And so, I'd love to do like a few cities in Italy. It would be wonderful. I love Italian food. My mom
Italian
was
food.
Italian.
Mm.
Yeah, Italian food.
Delicious. Yes, because
Just
your mother, yes, Italian.
yeah. I
And
wish I had learned Italian. I could give my conference in Italian. I can
but
give it in French, but not Italian.
my novel is written in Italian. Then an Italian novel that speaks about you, and but at the end of the interview, I will ask you to send a message to my readers, and but
Okay.
that will be the last question. If
Okay.
you hadn't chosen to be a scientist, what profession would you have pursued?
If I didn't choose to be a scientist, um, I, I didn't choose to be a scientist. So, you know, it just happened this way because I was interested
Happened
in
naturally.
nature of reality. But I would say I probably would have been a sculptor or painter, so I could
An
express
artist.
I, yeah, I could express my joy about nature, and I think nature is most amazing. So I would probably have been a painter to paint nature. But
Yes, because you love
yeah, I
nature and
I, I love nature.
yes.
And and I was a guide. I was a mountain guide. I was, a skier for many years. I taught skiing. I coached skiing. I did many, many things in sports. I was a scuba diver instructor. I dive master. I was like, many different sports. I taught, throughout the years when I was younger. So I love sports mostly so I get nature because I love being in nature. I love breathing the air of the mountains, the smell of the mountains, like seeing the animals, like all this is so inspiring to me.
Mm-mm. I agree with you. Um, what excites you the most and what makes you angry?
Oh, you have good questions. Um, what excite me the most, I think, is the potential of our world, the potential of humanity to like transcend and to really like become an amazing civilization. That excites me.
Mm-mm.
What makes me angry? Uh Many things. I think my biggest challenge in this life is to have been able to stay calm and patient. I can get impatient and angry and because I feel like um it's taking so long, and I see so many things to that is obvious to me, that is not necessarily obvious to others,
Okay.
right? So because it's obvious to me, I'm like, how can you not see this? Like, and it might not be just to one person or one person in general. It's not one person, but like even to humanity. Like, how can you guys do this? Like, what is going on? Like, how can you not see that you're being manipulated, or that you're like you're just repeating the same thing that people have been repeating, and you going falling in the same trap as everybody. Like, can you not fall in this trap? Like, let's rise. So for me, I think it's a really big exercise in patience, you
Mm.
know
Yes.
yeah. Yeah.
Okay.
Yeah.
Today, you are a famous scientist, but at the beginning of your research, did you ever consider giving up because your research was going against current beliefs?
Oh, many, many times.
Mm.
Many times. Because when I started, I decided I was a ski coach. I had reached the highest level in the Canadian ski industry. Uh, I was well, established. I had a lot of people that considered I was, one of the best, ski coach, ski instructor in Canada, and so on. And I decided to start doing this when I hung my skis And I said, okay, that's it. And I moved into a van, and because like that, I didn't have to pay rent and I didn't have to spend money. And I just studied full time, like 20 hours a day, like literally, like crazy amount, studying for 5 years, right?
Mhm.
And it was not to get famous. It was not like to uh, you know, for people to think I was a genius. It was just for me, you know. It was just for me. It's just because I wanted to understand the universe,
Very
right?
interesting. And
I, I it was, and so no, I and then I had a feeling like, okay, and then I found something that I thought was like really, I found a way to look at the universe, to look at physics in a way that, like, I thought this is the way. I didn't have all the proof. I didn't have like all the math. I didn't have all this, but conceptually it made sense. And I knew, like, if I went with that to the world, I would just hit a wall. I tried. I started talking to physicists. I started talking in physics conference, and the reception was, in many cases, really, really awful. Like, I had people screaming at me. I had people spitting in my face. Literally, I had one physicist moon me in a physics conference, like drop his pants and moon me. And you know, I my answer to that was, oh yeah, you see, it's all black holes. Anyway, I had all kinds of issues, and many of these moments were really difficult. I cried, you know. I had a lot of criticism from certain, trolls on the internet and all this. It's difficult. It was difficult for my kids. It was difficult for my wife. It was really like I had some very difficult moment. It's very painful. And and but whenever I would get this courage, it would be very short. Like it would be when I'm overtired, exhausted, don't feel like I can do it anymore. And but it would always be very short because I knew, like, oh, so what if I stopped right now? What do I do? Oh, I go and teach surfing, or I go back to skiing, and then, like, I know that, like, in like 2 days I'm gonna be like, no, I need to do physics. I love physics. I want, so, there's no way out. It's like,
I
no,
feel that. I feel that you like when you speak about physics, it's your life. I
yeah.
understand it.
It's when I'm in my joy. So I can't do anything else in my joy, even when it's difficult. That's the thing is people, they say, oh, but I want to do something that makes me joyful. It's like, yeah, okay, so you do something that makes you joyful, but in the thing that you're making you joyful, there's gonna be moments that are not joyful. There's gonna be moments that are really difficult. And this is when you have to push through, and the joy will come back, but you have to push through, you have to persevere, this is the incredible journey of life, and this is how you learn. When I used to teach skiing, I used to tell them that, like, sometimes when you teach skiing, and especially if you're trying to become a professional, like I was teaching professionals most of my ski career at the end. And you know, so people are training for years and years, and you're coaching them for years and years. And there's days where they're getting it, there's days where they're just having the worst day. They just can't put it together right, it's just not happening, and I always used to tell them, those are the most important days. those are the days where you learn. You're actually learning so much more that day that it feels like shit, that it doesn't feel good. Where the days that you're feeling good, everything's good. You're not trying to get better. You're already feeling great. You think you're the best year ever. But the day you're not feeling good, you're really thinking like, how can I feel better? How can I make it better? And these are the important moments. This is what defines, somebody that uh contributes something important in the world, or even in their life, in their own life, or somebody that's just lost and constantly going from one thing to the other. It might take a little bit of time, especially for young people, to find what brings them joy. But it's important to look for that, not to settle for something that doesn't,
Mm.
But you might have to do something you don't like all day so that you can do something at night that brings you joy. So that's okay. That's the same thing too. It's like, you, like for instance, I sit with Cyprien, Dr. Olivier, like, and we sit together for days and days, like writing physics, and it's so powerful and so energetic, and it's like, you feel the universe, you feel the creation like going through you. It's so powerful. And then I have to go and do administration, and like have to go and like, do some like tasks, like including like making sure that there's like toilet paper in the bathrooms and like, making sure it's okay. Those
But
are
you
not the
like your
things.
job, the universe, the energy that are inside you. Uh, I feel it when I listen to you. I understand that it's your life, really.
Yeah, yeah.
And would you like to send a message to the readers of Il profumo dell'Universo, the title of my novel, because they will discover you. Many people know about you, but some people will discover you. What do you want to say to these people? You want to
I would
them
like
to
to
know
say,
something
I would
about?
like to say, I would like to say that the universe is very Italian. Um, that like, the universe is passionate. It's it's aroma, it's like, it's amazing. It's dynamic, it's powerful. It's like, um it it's the source of your life, it's the source of your existence. It's the most amazing thing. So that maybe, hopefully, reading this book, they can have like a remembrance, like the spark in their eye, can come again, and like they can, hopefully, the aroma, the 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 scent of creation can come through them again.
Aroma, yes, perfume.
The
Okay, Mr.
perfume.
Haramein, I thank you for your kindness and availability, and I wish you good work and good luck for your future. Thank you very
Thank
much.
you.
Uh,
Thank you so much.
Thank you.